When we design machines, we typically think of
Whether you're
working out
creating
the
simple
sequence
or
of
complex
operations
designs,
first.
you'll
We don't
always
really
need to
focus
create
on the
reference
times,
planes
but
for
actually
sketching
the
or for assembling
dependencies
components.
between different events.
In SolidWorks
That's one of the
2010,
differences
we
between
create
Motion
reference
in
planes in a
2009
whole
and
new way,
2010.
in fact very similar to the way we create
2009 we
mates.
relied on keyframes
As
to
selections
position
are
things in
added,
sequencing,
familiar
which
constraint
makes it
icons
difficult to
show us
work
all the
based on
possible solutions.
an event finishing.
With up to
In
3
2010,
selections,
we've got a
this
great
new
new
method more than
capability
doubles
called
the number of
event-based
possible
simulation,
combinations
which enables
that
us
can
to
be
do a
used to
more
position a
realistic
plane.
approach to designing
For
our
example,
machines.
we can now create a
Let's
reference
take a look
plane
at the
through
feeding
2 axes or
mechanism
edges.
for the base plate.
Many people said they needed
So
to
here
create
we
a
have
plane
feeding
tangent to 2
mechanism,
cylinders
and we've got this
and be able to flip them
lifter,
to get the 4
which
possible
raises up,
combinations.
picks up the base plate, and then it
We
gets
can do that
extended
too.
across, dropped, and then it returns back.
We also
to
added a
continue
very
the
useful
operation.
one, mid-plane between
Let's
faces,
look at how we do that.
and they don't even need to be
So we have our
parallel.
existing,
Perfect for
keyframe
assembling
interface, but then
components
just click on the
and
event-based
adding
motion
planes to
button
imported parts with
to
drafted
bring up our
faces.
tabular interface to define the dependencies.
Sometimes you need to create sketches
start
of construction geometry
by
to get the
raising up
exact
the
plane you
lifter.
need, but not anymore.
And we'll
One
just
example
start
of
at
that is a
time 0
plane
just to get
tangent to a
things going.
face at an angle to a
Now
plane.
what we do is we provide an action
This
for a given
overhaul to the
task.
reference
So in
plane
this case, we're
interface
gonna
will
raise
make
the
models
lifter.
leaner and faster to create.
And it's a servo motor, which means it's positional based. So we can specify a particular value, say 112.5 millimeters. That's how far it's going to move relative to its current position. We specify a time that should do that operation over, and then an interpolation method. Cycloidal just means it starts and finishes with 0 acceleration. Now, what we need to do is, once the lifter touches the plate, is detach it from the tray. So to do that, we're going to base it on a sensor that's going to detect when the lifter touches the plate. And when it does, then we're going to go and turn off the mate that is currently locking that to the tray. It's just that easy. And then after we've detached it, we'll attach it to the lifter. So straight away at that same time, it's going to change what it's attached to. So we'll do that straight after the second task. And then we'll just pick the mate. So lock it to the lifter, and we turn that one on. Once it's reached the top of the lifting process, we then extend the lifter. So again, we'll base that on the task, which is raise lifter. You don't have to do these in any particular order because it's conditional based. So I'll pick this and change the value, and it's got to go 765. Over 2 seconds again, and we'll do cycloidal. And then once it's there, we need to lower the lifter. So straight after this task 4, we'll get our raise lifter operation, and because it's relative, it's pretty straightforward. We just bring it down minus 112.5, and we'll do it over 2 seconds again. And then we need to detach from lifter. So when it detects that the base plate's touching the carousel, we have a sensor to monitor that. And that's just, oops, sorry, this one here. And I think I pressed the wrong one there. Should be entry ram touches plate. There we go. When that's on, then we'll just detach that mate we activated, which is the plate lifter lock. And then straight after that task, attach to carousel. So you can see it's very operational based, which makes it very easy to work out the dependencies. And you'll see it's building up a Gantt diagram on the right hand side there, which shows those dependencies. Alright, once it's finished lowering the lifter, we can then retract it. And again, this is where the descriptions do help you a bit to pick the appropriate task. So we just get our extend actuator and change it to return back minus 765 over 2 seconds. And this is optional, but we'll actually get it to end when that task is complete. And that should be all there is to it. So you just click on calculate. So we'll see the lifter comes up, detects contact, lifts it up, locked together, it moves it across, starts to lower it down, detects the contact, locks it to the carousel, and continues on with the operation. So very quickly we were able to get that working, but what's really powerful is the ability to do change. For example, I might say, well, I want to speed up the raise and lower times, but slow down the extend times. So just like that, you'll see my Gantt chart updates. It doesn't know about these sensor-based dependencies until we run it. But you'll see it will update that on the fly as it solves. So it detects the contact there now. Zips it across really quick. Lowers it down really quick. So see, it's a very flexible system to very quickly evaluate different ways of sequencing things and really get your cycle time optimized for your whole system. Incredibly powerful and very easy to do just one location. When we look at the full model, you'll see that it's a little bit more in-depth. This one I didn't use the lockmates, that was a beta 1 restriction, and I haven't updated this model yet. But most of the work there is locking and unlocking components as they move through the system. But event-based simulations really is incredibly powerful for machine designers to go through and do these things. Not only that, remember we've got full physics-based motion. So if we select any of these components, for example, we could pick the base plate here and say look at velocity, and we'll just do magnitude for the time being. We can check to see if we're violating any requirements. For example, we may be concerned that we exceed certain accelerations that our package can't contain, or again for loading on joints and everything else. But we can see here it's just over that initial period where it gets positioned. So as I said, event-based simulation is an incredibly powerful tool, and I think there's a lot of value there for machine designers.